All right, we are today on 9.08 geometry notes. So let's start with the relationships between sine and cosine. And you should have picked up this sheet the last day you were in school, or you can print it out again, or you can write it on loose leaf or a tablet or a Chromebook or whatever you have. So relationships between sine and cosine, fill in the missing pieces. So we're just going to try to figure out what is the relationship between sine and cosine here. When we're working with any of our right triangle trig, remember that we always should be in degree mode as well. Right now, we're not going to actually type anything in. We're just talking about letters. So express sine of A. So I'm looking at angle A because it's always sine of the angle. And at the top of my paper, I always like to write my SOHCAHTOA. Sine is opposite over hypotenuse. So this is the opposite side. And here's the hypotenuse. So that would be A over C. Sine of, let's actually jump to cosine of A, since I already have angle A circled. Cosine is adjacent over hypotenuse. So that's going to be B over C. And now I'm going to erase that just to make sure it's clear for you guys. And I'm going to find angle B, circle angle B. So here's opposite from B, adjacent, which just means next to, and the hypotenuse, which is the longest side, always across from the right angle. Sine is opposite over hypotenuse, so opposite is lowercase b because it's a side length, over hypotenuse, which is lowercase c, across from capital C. And the cosine of angle B is adjacent over hypotenuse, so that's going to be lowercase a over lowercase c. So we are now asked to find the measure of angle C, which is marked as a 90-degree angle. And then it says find the measure of angle B plus the measure of angle A. So if I know that C is 90 degrees, and I know that there's 180 degrees in a triangle, if I subtract 90 from 180, that gives me 90 degrees. So I have 90 degrees left over to be divided between angle A and angle B. Maybe they're both 45. Maybe one's 30, one's 60. Any pair of numbers that add to 90 could work for A and B. Part number 7 says, what term based upon the answer to number 6 can be used to describe angle A and angle B? Well, if angles add to 90, then they are complementary. Express angle A in terms of angle B. So measure of angle A would be 90 minus the measure of angle B. So if B was 30, I would do 90 minus 30 gives me 60. What observations can be made regarding sine and cosine of angles A and angle B? So here I want you to look at this top part and look about what's true about the sine of A and the cosine of B. What's true about the sine of B and the cosine of A? And hopefully you notice that they're the same. So if I take the sine of A is A over C, the cosine of B is A over C. Why does that happen? Well, if I'm looking at angle A, what's adjacent to angle A is opposite from angle B. So that's why the sine of angle A would equal the cosine of angle B. So here we could say the sine of A equals the cosine of angle B, or the sine of angle B equals the cosine of angle A. In other words, knowing that A and B are complements of each other, the sine of the angle is equal to the cosine of the complement. Okay, so the sine of the angle, take out the, so sine of the angle, make it as straightforward as possible. Sine of the angle equals cosine of the complement, because together these two angles, A and B, have to add to 90 degrees because they're complementary. Based upon our findings, we can state that the sine of x equals the cosine of 90 minus x. And the cosine of x equals the sine of 90 minus x. And you could always check this to prove it in your calculator. Try typing in your calculator right now. Let's say let's make sure I'm in degree mode first, which I'm not, as this has been reset. Hit enter. And then if I do sine of 60, then try typing in cosine of its complement, 30. Would give us the same thing. You can try that with any angles that add to 90, just to kind of prove it to yourself. So let's do an example of a question that you could potentially see on a Regents exam. So number 9 says sine of x equals cosine of 31. So as soon as you see that sine and cosine are set equal to each other, you need to realize that these two angles are going to add to 90 degrees. So we're going to take x plus 31 equals 90. Subtract 31 from both sides. That gives us 59 degrees. Okay, so now I have sine equal to cosine. Anytime they're equal, the angles are going to add to 90. So 75 plus x equals 90. Subtract 75 from both sides, leaving us with 15. Let's go a little harder. Sine and cosine are equal, so their angles add to 90. So x minus 4 is the first angle, plus 50 is the second angle, equals 90. Combine your like terms. 50 minus 4 gives us 46. Subtract your 46 from both sides, and x is 44. Okay, so the next one, a little harder, but maybe you get the idea now. So try pausing the video, see if you can do it on your own. All right, again, sine and cosine are equal, so we take the two angles, set them equal to 90. So 2x plus 14 plus x minus 5 equals 90. I am quite confident that you guys can all combine like terms on your own and solve for x in that equation. If it is something that you're struggling with, then please text me, email me, send me a private message on Google Classroom. Let me know that you need help figuring any of these out if I don't give you enough work for them. All right, again, try pausing the video for number 13. See if you can do that on your own. This one's a little bit harder in terms of the algebra. So go ahead and try that. All right, again, we see sine and cosine equal to each other. So I'm going to set my two angles equal to 90. Now, since I have a fraction here, what I'm going to do is I'm just going to take the entire equation and multiply it through by 3. So that way, 3 times a third gives me just 1x. 3 times 30 is 90 plus 3x. 3 times 90 is 270. Now that looks a lot easier to solve. Add up to get your 4x. Solve. Final answer should be 45. And the last one, number 14, go ahead, pause the video, give it a try. All right, and for that one, the final answer should be x equals 20. All right, so that is, if you ever see sine and cosine set equal to each other, that's what you want to do. Next up, we're going to talk about something different. Whoops, I don't know what I am doing here. Go to the 9.08 notes. So if you need to pause and try to find those notes, go ahead and do that. We are going to talk about two different special right triangles, and these are extremely important. Next year, you will definitely need to know this. So really, really important. All right. So we've got an isosceles right triangle. An isosceles right triangle means it's got, I didn't want to do that. It has a right angle in it, and it's isosceles, so it has two congruent sides. You guys have to memorize this ratio. So whenever you have an isosceles right triangle, it means that the angles are going to be 45, 45, 90 because we've used up 90 degrees, so we have 90 left. It's isosceles, so those two angles have to be the same. So each 45. The part you have to memorize is that when you have this across from each of the 45-degree angles, it's going to be a ratio of 1 to 1, which makes sense because they're going to be the same. So if they were both 5, 5 over 5 reduces to 1. So they have to reduce to 1 on each of those sides. And then to find the side over here, you would multiply one of those sides by radical 2. So it's kind of cool because no matter what one of the sides is given to you, you could always find the other two without having to use Pythagorean theorem or SOHCAHTOA. And you can find the exact value, meaning in simplest radical form, not as a decimal. So we know this is 1, 1, and then rad 2. So 45, 45, 90 is in a ratio of 1, 1, rad 2. If you forget that and you know the numbers, then also think about, well, these two are the same, so they're both 1s. Also think rad 2 is bigger than 1, and the largest side should be across from the largest angle. Let's do a couple examples. We've got triangle MOP. MOP is an isosceles right triangle, so that tells me it's a 45, 45, 90 triangle. I like to label the inside of my triangle with my ratio, just so I remember it. So 1, 1, rad 2. Angle O, we said is the right angle. We've got that. Lowercase m, remember sides, we use lowercase letters, and that means that lowercase m is across from capital angle M. So this is going to be lowercase m over here. We want to find the other two sides. So we don't have enough information to use Pythagorean theorem because we only have one side. If we had two sides, we could use Pythagorean theorem, but we only have one. Could we use SOHCAHTOA? Well, we could, but if we were looking for this hypotenuse over here, it would give us a decimal, and we want to use these to find exact values. So what I'm going to do is I'm going to kind of look inside the triangle and say, okay, first of all, this is a 1 and this is a 1. So these are the same. So I already found that P is 6 radical 7. Now I want to find side O. So to find side O, I want to think inside the triangle, how do I get from a 1 to a 1 rad 2? Well, I would need to multiply by radical 2. 1 times rad 2 gives me 1 rad 2. Whatever I do to the inside, I'm going to do to the outside. So to get from this side, outside 6 rad 7, to get to here, I'm going to multiply by rad 2 on the outside. So I'm going to write it over here. So 6 rad 7 times rad 2. When we multiply, you can multiply radicals together and non-radicals together. So this is like 6 times 1 is 6. Rad 7 times rad 2 is rad 14. And always look for ways to put it into simplest radical form. So we take we look at our factors of 14, 7, and 2. We don't have a perfect square. So our final answer there would be 6 radical 14, which would be side O. And side P is 6 radical 7. All right. Number 2. Number 2, we've got triangle. I'm going to change how it looks because I think it's important you don't see them in the same position every time because they won't always be. Angle T is our right angle, which means M and O can be either place. It's isosceles and it's right, meaning it's a 45, 45, 90 triangle. On the inside of the triangle, I'm going to write my ratio. So 1 across from the 45, across from the other 45 is a 1, and across from the 90 is 1 rad 2. It says lowercase t is 5, so across from capital T is my side t, so they gave me the hypotenuse this time. Now I want to get from the 1 rad 2, so I'm looking on the inside first. I want to go from a rad 2 to a 1. So think to yourself, am I getting bigger or smaller? Should I multiply or divide? In this case, we're getting smaller, so we want to divide. I'm going to divide by rad 2 because rad 2 divided by rad 2 gives me 1. So if I can get to a 1 by dividing by rad 2 on the inside, I want to do the same thing to the outside. So I'm going to divide my outside number by rad 2. So I'm going to take 5 divided by rad 2. Well, now we have a problem because we have a radical in the denominator, and we can't leave that in the denominator. So we're going to multiply both the top and the bottom by rad 2, giving us 5 rad 2 over 2 is going to be this side up here. And then we know these two sides are the same because it's isosceles. This is also going to be 5 rad 2 over 2. So 5 rad 2 over 2 is both M and side O for that one. Okay, let's go on to the next one. So we've got, here we go, a 30, 60, 90 triangle. So let's make this our 90, 30, and 60. The ratio you want to memorize for this one, and this one's obviously a little bit harder because it's not isosceles and we don't have the same side lengths for the two legs. Across from the 30 is going to be your 1. Think about 1 is the smallest number, 30 degrees is the smallest angle out of 30, 60, and 90. 60 degrees is going to be your radical 3. Again, that is your next largest angle and your next largest number. And then across from the hypotenuse, the 90-degree angle is going to be the 2. So again, remember, longest side in the triangle is across from the largest angle. 2 is the biggest number. And if you're not sure about that, because you don't know what radical 3 is, type in your calculator the square root of 3, and it gives you about 1.732. So that is right between 1 and 2. So 60 is right between 30 and 90, so 60 matches up with the rad 3. Let's try one here. So we've got triangle rat. R is 30 degrees, I'll put that up here. A is 90, and T is 60. Lowercase r is 12, so that's going to be across from capital R. So over here, so it'd be side AT is 12. On the inside of the triangle, I'm going to label. So across from the 30 is my 1, across from the 60 is my rad 3, and across from the 90 is my 2. With these, what's really, really, really important to remember is that you always want to find the smallest leg first. Always find the shortest leg first. Will make your life much easier. That means you're always going to and from the 1. I don't want you trying to go from the 2 to the rad 3, or from the rad 3 to the 2. I always want you to go to the 1 or back to the 1. For example, if I gave you this side over here was the 1, then how do I get from a 1 to a 2? Multiply by 2. How do I get from a 1 to a rad 3? Multiply by rad 3. How do I get from a rad 3 to a 1? I would divide by rad 3. And how do I get from a 2 to a 1? I would divide by 2. So you're always just dividing or multiplying by 2 or rad 3. And that's what this says over here. You don't need to memorize those. It's just kind of what you would do. S stands for short leg, sleg. La leg is the long leg. But really, you can just figure it out by looking at the triangle. So if you had to go from 2 to rad 3, then you'd have to multiply by rad 3 and divide by 2, which is just too much work. So always go to and from the 1. All right, so we are given R is 12. Lucky for us, we are given the short leg, so we can find either one next. So let's say I want to get to the 2. How do I get from a 1 to a 2? Am I getting bigger or smaller? I'm getting bigger, so I want to multiply. So I'm going to multiply by 2. 1 times 2 is 2. Whatever I do to the inside, I do to the outside. So 12 times 2 gives me 24. So now I know across from angle A is side A is 24. Okay, and then next, I want to find side T. So to find side T, I'm going to go to and from the 1. So I want to go from a 1 to a rad 3. I'm getting bigger, so I'm going to multiply by rad 3. So that's what I'm going to do to the outside. So 12 times rad 3 gives me just 12 rad 3. So side T is going to be 12 rad 3. And that's already in simplest radical form, so we're done. All right, let's try number 4. Triangle LMP. So I'm going to draw it this way this time. So L is 30, M is 90, and P is 60. Lowercase p is 16, so I'm going to put that over here. Find sides M and L. So on the inside of the triangle, I want to write my ratio. So across from the 30 rather, is a 1. Across from the 60, rad 3, and across from the 90 is a 2. We always want to go to and from the 1. So we do not have the 1 this time. We're given the side that is with the rad 3. So I want to go from a rad 3 to a 1. How do I do that? Well, I'm getting smaller, so I'm going to divide by rad 3. Whatever I do to the inside, I'm going to do to the outside. So I'm going to write it over here. 16 divided by rad 3. The problem, we have a radical in the denominator, so we have to multiply the top and the bottom by rad 3, giving us 16 rad 3 over 3. And that is going to be side L. Now I just need to find side M, the hypotenuse over here. So we always go to and from the 1. So now that I found this 1, I want to go to the 2. I'm getting bigger, so I multiply by 2. So I'm going to take 16 rad 3 over 3, which was the side with the 1, and multiply that by 2. Since it's a fraction, I'm going to put 2 over 1. Multiply straight across the top, so 16 times 2 is 32 rad 3. Remember, the non-radical, 16 and 2, can get multiplied. The radical just comes along, and 3 times 1 is 3. And that is going to be side M. So 32 rad 3 over 3. Again, notice these are all exact values, meaning they're radicals, written in simplest radical form. And the last one, if you're feeling confident and you kind of get the idea, try pausing it and try it on your own. All right, so we've got, let's make the triangle like this. R is 30, A is 90, T is 60. Lowercase a is 5 rad 3. Find the other two sides, R and T. So what we want to do is label the inside. So across from the 30, over here is a 1. Across from the 60 is rad 3. And across from the 90 is 2. We are not given the side with the 1, so I want to find that side first. I'm given the side that has the 2. So to get from a 2 to a 1, I want to divide by 2. So I'm going to take 5 radical 3 on the outside and divide that by 2. Well, there's not a whole lot I can do from there, so I already have the radical in the numerator, and everything's reduced, so that's side R. Now I want to get to the rad 3. Always go to and from the 1. So now that I found this side, I'm thinking I want to go from this side to the rad 3. To get from a 1 to a rad 3, I'm getting bigger, so I'm going to multiply by rad 3. So that's what I'm going to do on the outside. So I'll take 5 rad 3 over 2 times rad 3. Let's make it into a fraction. Now I have my non-radicals. 5 times 1 is 5. My radicals, rad 3 times rad 3, is really just 3 because that's rad 9, which is 3. 2 times 1 is 2. I can simplify this a little bit more to get 15 over 2 is going to give me side T. And those are our two answers. All right, this is the rest of 9.08, kind of a compilation of different things. So now we're going to find the area of a triangle. So you guys have already learned that when you are finding the area of a triangle, the area is 1/2 base times height, the length of the base times the length of the height divided by 2. So the issue with that is you can't always find those things with the given information. So before we left, we talked about how to use if we had a coordinate grid and we drew a rectangle around the triangle, and then we figured out the area of the rectangle and subtracted out the areas of the triangles to find the original triangle that we wanted. But what if it's not drawn on a grid and we don't have the length of the height and or the base? What we do then is we have another formula. So to find the area of a triangle, you can also use this formula. They use a K, but it's if you use an A, that's fine too, is 1/2 AB sine of angle C. In order to use this, you have to have side angle side, meaning you have to know two sides and the included angle between them. So right here, we know the two sides are 12 and 9, and the included angle between them is 30 degrees. So I have side angle side, so I can use K equals 1/2 AB sine C. Remember, lowercase letters are the lengths of sides. Capital letters is an angle. All right, so we've got 1/2. Our side lengths are 12 times 9 times sine of our angle, which is 30 degrees. So we can type this one right into your calculator. And we get 0.5 or 1/2 times 9 times 12 times the sine of 30. Make sure you're in degree mode. Will give us 27, and that's just units squared. Would be the area of that triangle. And I think these numbers are actually off. Maybe not. Would be number 7. Find the area of triangle CLV. So let's draw this triangle, if it will let me. There we go, kind of. CLV. L is 80. Angle C is 65. Lowercase l, so that's across from angle L, is 22. Lowercase c across from angle C is 17. So I look at this triangle and I ask myself, do I have side angle side? And the answer is no. So I know this side and I know this side. So what angle would I need to know? What angle would be included between those two sides? And that would be angle V. Well, how do we find angle V? Well, we do know that the three angles here add to 180. So I could do 80 plus 65 plus the measure of angle V equals 180. And then solve for angle V that way, which would be 35 degrees. Once I know that's 35, now I have side angle side, so I can do 1/2 17 times 22 times the sine of 35 degrees. Type that into your calculator. It doesn't say it around here, so we're just going to write out that entire decimal. And that, again, would be in units squared, would be our final answer. And I think that's the last one that you guys have on your papers. All right, and that is it for us. And stay healthy, love math, and pie out.